In this video, I'll be covering the Pre-Calculus Semester 2 review problems. The very first one is actually redesigned, and that reads the tangent parentheses 3x plus pi over 2. And what you have to do is show the shifting that occurs and the changes that occur. For this very first one, I have to factor out the 3. You never want to have a number in front of x other than 1 inside the parentheses. So when I factor it out, it equals the tangent with 3 pulled out. And I have an x right here, and then I take pi over 2. And when I factor out a 3, I get pi over 6. In other words, 3 times pi over 6 is pi over 2. So my phase shift is going to actually be right here, and it's pi over 6 to the left because it's the opposite of this. The period is always pi over b. And the b value is the number that is right adjacent to x. It's the 3, so it's pi over 3. For number 2, where they asked for the 5 trig functions, if you're given cosecant of x and cosine is positive, if the cosecant of x is equal to 5, then that means that 5 is also equal to 1 over sine of x. Now, if I flip 5 into 1/5, and I flip this fraction here into sine of x over 1, then I know what sine of x is equal to. It's opposite over adjacent over hypotenuse. So I have a 1 here for the opposite and a 5 here. Now if I use Pythagorean theorem, I can come up with this side, which is 2 root 6. So now I have enough to find cosine, sine, tangent, and then I can do the secant and cosecant as well. So the cosine is just going to be this number over 5, opposite or rather adjacent over hypotenuse. The tangent is going to be 1 over 2 root 6. You should be able to rationalize 2 root 6 into root 6 over 12 by multiplying top and bottom by root 6. And then for the secant, that's going to be equal to 1 over the cosine. So I just go up to my cosine value and flip it, 5 over 2 root 6, and then again I rationalize. And when I do, I'll have 2 times 6 on the bottom, which is 12, and 5 times root 6 on the top. And that's my answer. For cotangent, I just take my tangent value, which is 1 over 2 root 6, and flip it, and I get 2 root 6 over 1. For problem number 3, they ask you to simplify this identity, and to simplify it, you only have to know what the identity is of cosine squared theta plus 1. Now, it's important that you know these identities, even though they may be on your review sheet on the back, because if you don't have familiarity with them, then having them on the back probably won't do much good. So we know the cotangent squared of x plus 1, or theta plus 1, is equal to cosecant squared theta. And I also know that cosecant squared theta divided into 1, that this whole thing is really a form of sine, so sine squared theta is your answer. For number 4, we're asking for the arcsine of 0.96. Remember, arcsine is going to give you what the angle is, theta. And so this value right here is giving you the height in a triangle that is the sine value. In other words, in your triangle, you're going to have a sine value height right here, which is 0.96. And so we're trying to find out what the angle is. And I can do that by just calculating it on my calculator and punch in sine inverse, and I get my answer. Make sure you're in radian mode, and throughout the final exam, always check your mode button. You can tell that this is in radian mode because there are no degree symbols, and because this is a value that's less than 1. On number 5, this one was a little more involved. Whenever you see that you've got a composition of functions where I have tangent of arc cosine or tangent of arc sine or anything, the first thing you do is you look at this value right there, really being given the ratio, and arc cosine or cosine inverse has the ratio, and that ultimately will give you, right inside the parentheses, the angle theta. So they're really asking overall, what's the tangent of theta? So what you're going to ultimately end up with is the opposite over the adjacent. In order to do that, you've got to have a triangle. So we start out by setting up what arc cosine of 2 over x really means. And to reinterpret it, we could say that cosine of theta, because arc cosine of any ratio is a theta value, an angle, that we're going to get rid of arc and turn it just into cosine of theta is equal to 2 over x. Keep in mind 2 over x is suggested that it's positive. There's nothing here to say it's negative. So the first thing I do is I make my triangle and I show 2 as the adjacent and x is the hypotenuse, which is what cosine is. But the other thing about cosine is that it can be in quadrant number 4, and that shows as a number 2. That should really be quadrant 4 right there. So that's a 4. And that's where cosine is positive. So if I look at this value right here as the cosine value, then if I drew another triangle down below, then that would also, this angle would also give me the same cosine value. So the x is the hypotenuse of both triangles. Then I look at tangent, which is the last thing in our expression that we have to do. We've already dealt with this. We've drawn a picture of this. And the tangent of theta is going to be opposite over adjacent. In order to get this, I use Pythagorean theorem with these two values, and that's going to be divided by 2 to get the tangent. So this is your answer for what tangent is. Finally, on number 6, and then we'll stop briefly, is asking here, and you have to read carefully, so make sure you underline the keywords in your questions. It asked for a triangle altitude. So it said find the altitude if you are going to draw it from AB. So the altitude goes up 90 degrees, and we have to use these two values right here, and that suggests the hypotenuse and the opposite side to the angle. Opposite over hypotenuse is SOHCAHTOA. That's sine is going to be opposite over hypotenuse, so I just write sine 50. I isolate x by multiplying by 12 both sides. Make sure you're in degree mode in your calculator. Always check your mode. And then when I do, I've got 9.193. And if they have this in meters, then I need to put the units down, which are meters. It's asking you to draw a right triangle, ABC, and we've got it right here, A, B, and C, right angle right there. With angle A being 54, and side B, which is opposite angle B, being 12.4 centimeters. Having that information, they want you to find the other two sides, and they want you to find the other angle. The easiest thing to do is to find the angle first, because all three angles add up to 180, so 54 plus 90 gives you 144. Subtract that from 180, and you can end up with 36 degrees. The other way to do it is just to add 54 plus this angle. Those two have to add up to 90, and I get 36 as well. The next thing is to figure out what side A is. And I use side A because if I use these two sides right here, then that's tangent. So the tangent of this angle right here is equal to the opposite over the adjacent, A over 12.4. I can isolate A by multiplying by 12.4. Make sure you're in degree mode in your calculator, and you get your answer. That's an approximate answer. Now that I've got that answer, the last thing to find is side C. Always use the given information to find another side. Don't use what you just found because it might be wrong. So we're going to take 12.4 and C, and those two right there are a cosine relationship, adjacent over hypotenuse. And so again, I'm going to have to isolate C, and I can do that by multiplying both sides by C and then dividing both sides by cosine of 54. Or I can just switch these two values right here, their position. So I get C divided as a division problem, and I do the division using degree mode on the calculator, and there's my answer. Don't forget for this one that they did give you centimeters, so you want to make sure you write down what the units are when you put your answer or select your answer on the final. On number 8, this one is a angle addition problem where you have plus minus addition. And so we have sine of 2 pi over 3 and 5 pi over 6. I'm going to go ahead and call this U, and I'm going to call this V. And so I have sine of U cosine of V plus cosine of U sine of V. Now the other thing I have to do is look at 2 pi over 3 and see where that sits. I know that the sine, because this is the positive value, I know that sine is going to be positive in the first two quadrants. I know the cosine is going to be positive in these two quadrants, and tangent is positive first and third. This particular drawing you may want to include in your notes. So because I know that 2 pi over 3 is going to be greater than pi over 2, I must be in this quadrant because I have not reached 3 pi over 3. So I know that my answer is going to be positive for sine of 2 pi over 3, comes out to root 3 over 2. You get that from your table of sine, cosine, and tangent values, which you also probably want to include in your note sheet. Then I look at cosine of 5 pi over 6. Remember, 5 pi over 6 is going to sit just shy of a total of pi. If you look at cosine positive here, then over on this side cosine is negative, and that's where we get the negative from. Cosine of 2 pi over 3 is also in this half. That's all negative for cosine, so I get a negative 1/2. And then finally, we have 1/2 for sine of 5 pi over 6, because 5 pi over 6 sits right about here, and that's going to be a positive value. And then I multiply out my values, add them, and I get my answer. For number 9, this one is a powerful problem because in doing this, it comes out of chapter 5, I believe. You have an interval from 0 to 2 pi, and that interval does not include 2 pi. So the first thing you do is isolate what cosine of x is. So I move the 1 over, I move the 2 over, and right there the temptation is to say, well, I know that if x is pi over 3, then I've got 1/2 as my answer. But that's not all. What I need to do is draw this situation. So the cosine of some unknown angle has a base of a triangle equal to 1/2. So if I draw my triangle, I have to notice that this is a positive value. So because it's positive, I have cosine as positive, and I have my hypotenuse of 2, which is also positive in itself. Now this 2 right down here is also positive, and the one right here is as well positive. So my radii are always positive. That means I have 2 possible triangles, thus I have 2 possible angles that are going to give me this height of 1/2. The thing is, I have to decide how to reach those 2 values. And to get those 2 values, one of them is going to be just up to here, and that's going to be the pi over 3 value. But the other one, you would have to circle all the way through what I call no man's land to reach this spot right here. And that's something you cannot do because this area is where cosine is negative. And we're saying in the problem that cosine is a positive relationship. So I've got to get down to here by some other means. The only way to do it is to go backwards, which is going to be a negative value. So instead of writing down 5 pi over 3, which really can't be done, I would simply say it's negative pi over 3. And that way I do not go into an area that is negative and the problem works. So the answer is pi over 3 and negative pi over 3, not 5 pi over 3. If we look at number 10, this is going to be an identity problem, and you should recognize this identity here as sine squared of x. If you look at cosecant and change it into sine or cosine, it becomes 1 over sine of x. And then the sine squared and the sine both divide out, and I end up with just sine of x on top. For number 11, this particular problem is out of chapter 5 as well. You have to find all 6 trig functions, and you're given 2 conditions. Now, the first thing I'd look at is where tangent is negative, and it's going to be negative in the second and in the fourth quadrant. Then I look at secant and turn it into 1 over cosine. And so I know that 1 over cosine of x is equal to negative 3. If that's true, then I can say that cosine of x is equal to negative 1/3. I just flipped everything. So the way I'm going to do the problem is to say cosine of x is negative 1/3, and then I draw my triangle. Keep in mind, though, I have to have my triangle sit either down in this quadrant or up in this quadrant because the restriction of tangent of x is less than 0. So it's got to meet both conditions. It's not going to work to have it down here because cosine down here in this area is a positive value, and we want a negative value. Remember, cosine is positive on this half, so we have to go to this side, and we have to overlap with tangent negative, and that's in the second quadrant. So I write down these 2 values in my triangle. I draw a right triangle. I know cosine is always going to be adjacent to the angle over the hypotenuse, so that's where my negative 1 comes in, because the hypotenuse is always going to be a positive number. So now I can figure out what this is by Pythagorean theorem. I'll just say 3 squared